Hello everyone, welcome to this next video on complex analysis. In this video we shall take up question from GATE 2003 and it is of 2 marks. The question says, let I be this particular integral, then what is the value of I out of these 4? So let us first see what is this given contour C that is given to be by this equation and having counterclockwise direction. So let us first see what is this equation. So we can rewrite it like this: x square by 1 by 2 plus y square divided by 2, that is equal to 1, or we can write this to be x divided by 1 by square root 2 whole square plus y divided by square root 2 whole square, that is equal to 1. So here this is the standard equation of ellipse having center at the point 0, 0 and whose x in intercept has value 1 by square root 2 and the y intercept has value square root 2. So these are the points. So let us first draw our ellipse, the curve C, and its orientation that is given to be in the clockwise direction, so it is positively oriented. So now in order to calculate what is this integral, let us first check all the singularities. So let us first assume our function fz to be cot pi z divided by z minus iota whole square. So let us first check all the singularity points, all the points where we have problem. That means the points where this function is not analytic. So we see at z is equal to iota, we have a double pole. How? Because when you substitute iota, so you see corresponding to iota, z minus iota term is present in the denominator with power 2. So that means we have a double pole at this particular point. So in order to calculate this integral, which is defined to be over this closed contour C, cot pi z divided by z minus iota whole square, so we'll use the residues theorem. So that would be 2 pi iota multiplied by the sum of all the residues. So we'll be calculating the residue of this function f of z at the point z is equal to iota. So we just have to evaluate this expression. So for that you must know what is the formula for calculating residue. If you are calculating the residue at some point say z is equal to a, having order n. So for that the formula is, you just take the limit z goes to a and then you define 1 by n minus 1 factorial, 1 by n minus 1 factorial, and then the n minus 1th derivative of the function z minus a raised to power n into f of z. So this is the formula to calculate the residue. So we just apply the same over here. So we would have limit z goes to iota because our point here is iota, and then we would have 1 by 2 minus 1 factorial, then the first derivative with respect to z of the function z minus iota square multiplied by f of z. So let us solve this quickly. So we would have 2 pi iota and then limit z goes to iota, and then it would be 1, and then the first derivative of this function z minus iota square, and then what is f of z? F of z is cot pi z divided by z minus iota whole square. So now this quantity and this quantity cancels, and we have to take the derivative of this function cot pi z. The derivative of cot pi z is simply minus cosecant square pi z multiplied by pi. So this is the derivative. Now if you substitute the limit, so we would have 2 pi iota multiplied by minus pi cosecant square pi iota. So you can rewrite this or you can simplify this a bit. So we would have minus 2 pi square iota divided by sine square pi iota. So now we can use this result. We very well know that sine iota z, that is equivalent to iota sine hyperbolic z. So this is a relation between the circular and the hyperbolic functions. So we can substitute the hyperbolic functions instead of this sine iota z. Why? Because if you see your options, so here there is no term containing sine iota pi, and we only have the hyperbolic term. So in order to check, so obviously this is not the answer, because we have terms not 0, right? So just simply put this value over here. So after calculation and after simplification, you will end up with this quantity 2 pi square iota divided by sine hyperbolic square pi. So this would be your final answer. So let us have a look at our options. So from here we see 2 pi square iota divided by sine hyperbolic square pi is the correct option. So here we got option D as our correct option. So that is it for this video. Thank you for watching.